Hello, kiddos. I'm gonna go ahead and walk you through some of these naming problems. So this paper, I posted it yesterday, so you all should have it. Naming acids. I want to quickly just review the rules for naming acids. All right, so what you're going to do, you're going to look at the number of oxygens that's in the formula itself. Okay, so that's one column. Number of oxygens. And then we have a rule that we're going to apply to it. Now, if your number of oxygens in the formula, if there is one more oxygen than the reference ion, okay, then remember what the rule is. If there's one more, then our rule, prefix per, ending ic, okay? Now when I say reference ion, I mean the polyatomic ion that ends in ATE, carbonate, chromate, nitrate, phosphate, sulfate. If it ends in ATE, that's your reference ion. So one more, then we prefix per, we have the root of that ion's name and end it with ic. Percarbonic, if it's carbonate. If it's sulfate, persulfic. Okay, and of course all these names end with the word acid. So if it's equal number of oxygen, okay, then we just end it with IC. That's our rule. You just have the root name ending with IC. Okay, carbonic, sulfic. Okay, now if the name ends, okay. So if we have one less oxygen than our reference ion, then we're just going to have an ending of OUS. And then if we have two less oxygens than our reference ion, we're going to have an ending that starts with the prefix hypo and ends with OUS. So this little chart that we made, you're pretty much going to have to commit it to memory. Okay? So let me show you how that works, how that plays out. Let's go up here. The binary acids, those are easy. We can do those really quickly. All of these start and end the same way. They all begin with the prefix hydro, and you have the root of the ion, and they end in IC, ic. They're all going to end in IC. So this one, the first one, see if I can blow it up enough so I can write. First one's going to start with hydro, and then that's fluorine, so it's fluor. Rick, and they all end with acid. So that one's hydrofluoric acid. Okay? Hydrofluoric acid. This one will be the same thing. They all start with hydro. That's sulfur. Sulfuric acid. Okay, these binary acids are very, very simple to name. That's all there is to it, no tricks. Hydro, that's iodine. Iodic acid, very easy. What do you suppose these two are? Hydro, chloric acid. That one's chlorine. And then how about over here? We have hydro. That's bromine. So how do you think this one's going to end? If you said bromic acid, you are correct. So these binary acids are very, very simple. Prefix hydro, you have the root of the ion, and they end in IC. Okay? These oxyacids, these can be a little bit more complicated. Okay, for the oxyacids, we need a reference ion. So what ion, I'm asking you a question, what ion has carbon and oxygen and ends in ATE? Which ion has both carbon and oxygen and ends in ATE? Carbonate. Okay, that one's going to be carbonate. So carbonate is CO3. Our formula has 4 oxygens. The carbonate ion has 3 oxygens, right? 4 and 3. So what rule applies? What rule applies? Our formula has 4 oxygens. The carbonate ion only has 3. So our ion has 1 more oxygen than the reference point ion. So per root ic. That's how this one is going to be named. Per root and ic. Okay, so this one is going to be per carbonic acid. Per carbonic acid. Per, then root of the ion name, and the ending is IC. Per ic. Okay, the next one, H2CO3, equal numbers of oxygen. What rule do we follow if there's equals numbers of oxygen? What's that rule? Let's go down. Equal number, IC. So this one is going to simply be carbonic acid. See how that works? Carbonic acid. Okay, now we have H2CO2. My acid has 2 oxygens and the ion has 3. What rule does that follow? 1 less. If it's 1 less, we're going to have our ending of OUS. So this one is simply going to be carbonous acid. And then finally, H2CO. Remember, if there's no subscript at the end of the element, it's just understood that there's 1. It's just same thing as having a subscript of 1. Okay? So this one has 1 oxygen and our ion has 3. So our formula has 2 less oxygens. So our rule is hypo root then OUS. Hypo root OUS. Okay? So we're going to write hypo carbonous hypocarbonous acid. All right. So I hope you see how it goes. See the pattern that's going on. We're looking at the oxygens in the formula. Okay, 4, 3, 2, 1. We're comparing it to the oxygen of that 8 ion. In this case, it was carbonate. Okay, the second bunch, the second group, what's the 8 ion? Chlorine and oxygen. Chlorine and oxygen. That ends in ATE. That'll be chlorate. Okay, chlorate is ClO3. Now in the next bunch below, what's our ion that ends in ATE that has phosphorus and oxygen? That'll be phosphate. PO4. Okay, that's going to be phosphate. Don't worry about writing formulas. You probably can. You'll probably be able to do it at this point if you understand the rules. We'll hit on that later. All I'm focusing on right now is writing the names. Given the formulas, can you write the names? Okay. So go ahead and try the next 2 groups. That's pretty good practice to do on your own. Just remember these rules. Remember these rules. One more oxygen than the reference point ion per ick. Equal number of oxygens, ick. One less oxygens, OUS. Two less oxygens, hypo, OUS. Okay, so look over these. Look over the notes from yesterday. Try the rest of these problems on your own. And we do have a quiz coming up next week. For today, though, you do have an assignment. And check your classwork tab, because that's where it will be posted if you don't see it here. All right, kiddos. Happy Friday.